Hello everyone, welcome back to a new video of Insightful Academia, and today we're going to be talking about product rule and quotient rule. Previously on our derivative journey, we went over two rules, power rule and chain rule. And as a reminder of those two rules, for power rule, we're going to be taking the exponent and subtracting it by 1, and for the chain rule, we're going to be taking the derivative of the outside function and the derivative of the inside function and multiplying these two separately, as we have shown in the slide. So we're going to be expanding on these rules and using these rules in product rule and quotient rule to take more complicated derivatives. So starting with the product rule, if we have two functions multiplied together, two polynomials, we'll say x to the n, x to the n. It's a common mistake that students will use power rule for both of these and multiply together. However, this is incorrect. And what we're going to want to do is use the product rule. So what the product rule states is that you're going to take, if you have two functions multiplied by each other, you're going to take the derivative of one function, multiply it by the normal function of the other function, and then you're going to take the derivative of the other function and multiply it by the normal function. So we have f of x, and then we have our derivative, and we have g of x multiplied by its normal function. Then moving over, we have the derivative of g of x, and we have the normal function of f of x. So another way we can denote this is f prime multiplied by g, multiplied by g prime, multiplied by f. So let's look at some examples. So starting with our first one, we want to identify what's our f and what's our g. So starting off, 3x squared will equal our f of x, and 7x cubed is going to equal our g of x. That's always going to be our first step. We're going to define our f and g. Cool. So now we have this, let's go further and apply our equation. So again, how we're going to describe product rule, f prime g plus g prime f. And that's exactly what we have in this one. F prime g, f and g prime. So we take the derivative of these. This f prime is going to take the derivative, g is just going to go straight down, doesn't change. Now we're going to have f doesn't change in this side, and then g, which is going to change and taking that derivative. So now we can simplify more. We can go down to doing FOIL and multiplying these two together, multiplying these two guys together. So we come out with 42x cubed plus 63x to the fourth, which gives us a final answer of 105x to the fourth. It's important to remember our exponential rules as well. When using power rule or any derivatives, we have x to the m multiplied by x to the m. These two exponents are going to be adding together. Let's do another example of product rule. It's a similar type of question, as these are both polynomials with the structures of x to the n. However, product rule is going to work if f is either polynomial, a trig function, say sine x for example, natural logs, basically any function, product rule is going to work. So let's identify our f. F is 3x to the fourth. G is going to be 5x squared. Let's take the derivative of these. Derivative of f. G coming down. Derivative of f again. This is going to be the normal function of f. And now we have derivative of g. G prime, regular f, f prime, and g. Let's move on. We can simplify this more. Multiply these two functions together, these two functions, add our resultants, and you're going to end up getting 90x to the fifth. Alright, so here's some more examples you guys can do as practice, and the point of setting up these problems, so first thing we're going to want to do again is set up our f's for all of these. So we'll have f on the left side, g. One key thing to remember is that f and g are interchangeable. So the f can be any letter A to Z. Same thing with g. Doesn't need to be specific to these f and g. However, the order of these two do matter. And as long as in your equation that you have f derivative of g on this side, and then the respective functions not taking derivatives, it should be okay. So the entities coming out, 4x sine x plus x cosine x for the first one. Second one, 4x cubed cosine 2x minus 2x for the fourth sine 2x. And for the last one, cosine x secant x squared minus sine x tangent x. So again, we see in this bottom one that you don't need to only have polynomials. And then the middle one and the top one, we can combine polynomials and trig functions and we still get the same exact answer. As well, for this one, we're going to also have to use chain rule. So how do we take derivatives of these types of functions? Product rule will only work on this one. This function also does equal However, as long as these are both being multiplied by each other, it looks like we can use product rule. However, it'll be easier to stick with the quotient rule, as quotient rule is designed to attack problems like these. So similarly, we have a function of f on the top and g on the bottom. And we're going to follow this basic formula for all our problems with f and g, or commonly other ones you can see as well, is f of a and z. So define our f and x, 7x plus 4, g of x equals x squared plus 5. So let's plug this into our equation. So we're going to have f prime g plus f g prime g squared. Another technique you can do before actually plugging it into this equation and writing it all out, we can write out on the side what f prime is. 7. We know what f is now. Then we'll have g prime 2x plus 0 g x squared plus 5. So now we can use these and plug them in to their respective areas, if that makes it easier for you to solve. Okay, so let's simplify. Use FOIL. And on the bottom, you can simplify that more as well. And if you would, we're going to separate them as shown, perform FOIL, and solve. Simplifying more, on the top, our final answer is going to be 21x squared plus 8x plus 35 over x squared plus 5 squared. And if you want to evaluate the bottom, we can do that real quick. So then on the bottom we'll have x to the fourth 10x squared plus 25. These two are equal and they're the same answer. However, some of your teachers may require you to simplify further. So let's look at another example. Our first step was to define our f and our g. F of x, g of x. And then we're going to plug these both to our equation. So we can take the derivative of these before we plug in. We'll have 2. G, we'll have 2x plus cosine x. And be careful when you're taking your derivatives of sine x and cosine x. with your negatives. This will equal cosine x. But the derivative of cosine in any trig function with a c in it will have a negative value in it. So let's plug this into our equation now. F prime g plus f g prime over g squared. F prime g f g prime over g squared. Simplifying it out, we'll have to use FOIL again. And the bottom is going to remain as g squared. So this will be our simplified answer after going through it all. On the bottom, if we're going to expand that, x squared plus sine x sine x. And the same method of using FOIL will apply as how we did before. Okay, so let's look at some more examples. Before you guys start this one, the first method that we're always going to have to be using, technique, is always first defining our f and g, taking our f and g derivatives, and 3, going to plug into our equation. 4, we'll simplify. So after solving these will be our equation. And by separating these out by this term, that'll be represented in here, which is shown in the brackets. And then the f of g right here. Then g f squared will be on the bottom. I'll keep the same color network to keep it consistent. So bottom g squared, g prime or f g prime, and then f prime g of x. So as a recap of what we did today, we're going to have to use power rule and chain rule with a combination, either product rule or quotient rule of taking different derivatives. So our steps are always going to be identify our f and g functions, take the derivatives using the rules, and plug into the questions and simplify. Thank you for listening today. Remember, mastering calculus is like building a muscle. Practice, persistence, and patience are key. Keep exploring, keep questioning, and most importantly, keep enjoying math. Thank you so much for watching.